So we are going to be talking about making data science notebooks collaborative. What I really mean is we are going to discuss real-time collaboration. So this is something you might be used to from, for example, Google Docs or Figma or similar tools where you can just, send a link to all your friends or your colleague, even share it on Hacker News, whatever. All those people can come in and see the same content at the same time. Well, eventually same content, but we are going to get into that a tiny bit deeper. So yeah, this is it, but I'm going to start with like a short obligatory slide about me. So right now I am CTO at DeepNote. I'm not sure if many of you have heard about us so far. If not, I hope this is going to change really soon. We are making a collaborative data science platform. So really what we are enabling people to do is go and work on their data science projects together without any barriers, with spawning environment super quickly, everything is managed, everything is in cloud. So maybe doing something like Google Docs did for Microsoft Word like 10 years ago. Apart from that, before I started working at DeepNote, I did some artificial intelligence research at Imperial College London. So you can see like a couple of pictures here at the bottom. So I was really working on this robotic arm that was trying to take a piece of cloth from the ground and then lift it and hang it on the hanger. This was all trained in simulation, and then it was transferred to an actual real robot. And this was using deep reinforcement learning neural networks of that. So if you are by any chance interested in robotics or reinforcement learning, I will be super glad to talk about it. Cool. With this out of the way, I can really introduce the talk. So in the first couple minutes, we are going to be talking about Jupyter Notebook internals. I believe most of you guys have heard about Jupyter Notebooks, but maybe you did not yet have a look about what's going on under the hood. So I'm just going to uncover like a couple of basic building blocks. Then I'm going to talk about the real-time collaboration. I'm going to motivate the use case for it, and then I'm actually going to explain how it works. So all the technicalities. So this is really the meat of the talk. Then, like taking your data science environment from your laptop into the cloud brings a lot of security issues. So I'm just going to touch on those and tell you like how we are solving some of them if you're interested. And at the very end, if the time allows, I'm just going to give like a quick demo of DeepNote as it is running right now. Okay, so starting up, Jupyter Notebook. I'm not sure how to do this. I was hoping to have like a quick show of hands about how many people are familiar with Jupyter Notebooks or using them. I thought there was like this thing in Zoom where you can just raise hand or something. Is this the thing or?
There is.
Yes, we are raising the hands. You can
okay.
see. Open the
I see a up finger. I see people raising hands. I believe that I can just take it as like I've got a normal sample of the whole population of data scientists in my talk. So I assume that 80% of you guys have raised hands because that's like the sample of people in data scientist population around the world that are currently using Jupyter Notebooks. So you could say this is really like a big prevalent tool in a sense. Okay. Apart from that, Jupyter Notebook is really moving from like the domain of data science into also different fields, biology, and even, like DevOps engineering. I remember a story from a guy at Netflix who told me that every single scheduled job in Netflix, and so like cron jobs or the data pipelines, all these are Jupyter Notebooks. And the idea is that the Jupyter Notebook is a familiar interface. Pretty much 80% of the engineers have already met the Jupyter Notebooks, more or less. So when people join Netflix, they already know how Jupyter Notebooks looks like, they're familiar with it. So it's only natural that if they come in and see the user interface for a scheduled job to be Jupyter Notebook, they can immediately do work. For example, there was this engineering manager that hadn't written code for years because he was now like an important manager. And he got paged because like somebody didn't answer to a page. So the page escalated and escalated up to this guy. And this guy, not knowing, well, forgetting how to write code, just said, like, what the hell, I'm just gonna try it. So he clicked on the link. He saw a Jupyter Notebook, but he saw the documentation because there is like this markdown data. He saw the code, he saw the error message, he saw everything in one place. He was able to identify the mistake, the error, and quickly fix it. This wouldn't be possible if like the logs were in one place, if the code was in another place, documentation in some sort of Git repo or whatever. So really Jupyter Notebook is omnipotent, omnipresent, and it's like a really great tool. Cool. Moving on. I'm wondering if any of you guys have already looked inside the Jupyter Notebook, like what it actually is. What's the file on the disk? So it really is just a JSON file. If you are not familiar, JSON is like a very popular format for communication that is human readable. So pretty much all of current internet is running on JSON files being exchanged back and forth. As you can see, this is, for example, a Jupyter Notebook. Any one of you guys have any ideas what these Jupyter Notebooks might be doing? It's not the easiest way to read it, but to give you a hint, the source code of the cell is over here. So it's literally just like hard-coded string saying print hello world. As we are in the Python group, I'm hoping that this is going to be familiar to you guys. This literally just outputs hello world. And over here, what we can see is the actual output. So we can see that hello world was printed to a standard output. So this is really just the single cell inside the notebook. Otherwise, there is some metadata saying that this is like a Python notebook. There is a notebook format. This is not particularly important, but there are like 5 versions of Jupyter Notebook files that exist. Pretty much all notebooks today are version 4. We have seen in DeepNote like a couple of Jupyter Notebooks version 3, but nobody really cares about those anymore. Cool. So now when we know what the Jupyter Notebook actually is on the disk, it's just a JSON file, I can dive into the actual architecture of the Jupyter Notebook world itself. I'm not really good at making those well, diagrams. So I just stole these from the Jupyter documentation. You can also find it there. But really what this means is that you are the user. You are just sitting here. There is a browser in front of you. And you are just seeing, you know, like the JavaScript and HTML that was transferred to you, and you are seeing all the cells and all the code. This communicates with the so-called notebook server. Notebook server is a component that is actually taking those notebooks and saving them to the disk. So it has an idea that there is like, you know, 10 cells in your notebook. The cells contain this code. This is the order of the cells, and it can pass this to the disk. It can serve you the data to the browser. But it's not doing anything with the code itself. It's not executing anything. For that, we've got a kernel component. So kernel component is the one that is really running your code. And this is language specific. You probably know there is like a Python kernel. The most common one is IPython, but there are some others. There is Xius Python, and well, there is a big bunch. But you might have used other tools. If you use R, there is kernels for R, there is kernel for Bash, kernel for SQL, like there is a big bunch of those. Well, and the kernel is actually not necessary to do the editing of the notebooks. You can have like a standalone notebook server without any kernel, and you can be just, you know, like editing your notebook, saving it every now and then, and everything works just nice, but you are not executing the code. So now if we zoom in on the kernel component over here for a moment, what we can see is, I'm just gonna move this again a tiny bit. What we can see is that there is really, this is a simple component. There is like an execution request coming in. This is just the code. So for example, print hello world. What is coming out is an execution reply. So this is just saying that this got executed. And there is a side effect. So for example, the stream saying hello world, as we had from an example. So the kernel has no idea about the fact that there is like a notebook that has cells or anything. You are literally giving it like the data from a cell, and then it gets executed and you get the reply. But it doesn't know that it was a cell. It could have been just like, you know, like a string that you wrote. All right. So this is really all the moving blocks that I wanted to talk about the Jupyter internals, because this is going to show us how to, what we need to actually build like real-time collaboration components. Cool. So now let's talk a bit about real-time collaboration. I'm going to start by telling you something about why real-time collaboration actually matters, what's so important about it. So what we are looking at here is some sort of like a usual company. There is some legal department, some managers, marketing, but here at the center, it's us, you know, the data science team, the people using Python or SQL or whatever to do some something with data. And it's a couple of people, you know, and those people might want to collaborate for a lot of different reasons. For example, this guy might want to get a code review from this guy, so he can send a notebook and get some sort of comments. They can even jump on the call or look at the same notebook, they can edit it together. But apart from this, there is a lot of other use cases. For example, this guy can go on a holiday and the other people want to look at his environment. If his environment is offline inside his computer, there is like no way they can access it. Otherwise, maybe this guy starts running a model and also goes home for or goes to a theater, whatever, right? If the model is running in classic Jupyter, there is no way to check progress. The other people can't access it. So the collaboration helps in all those use cases. Maybe one final thing is, maybe some of you people are familiar with using Git. Is that right? Git for version control. So it's like a tool that allows you to version control your code. And in some situations, you might end up with two branches that you are merging, and this produces some sort of merge conflicts, potentially. If you are looking at the same code in real time, and you can share it, there is no concept of a merge conflict because you are always looking at the same state, same ground truth. However, like outside of the data science teams, the benefits of real-time collaboration are also pretty big. So for example, if you are communicating marketing, you are probably, you know, like taking screenshots of your graphs or of your outputs and then sending them slides. But now if you have like a collaborative environment in cloud, you can just send them a link and tell them, you know, guys, here is all the graphs. We can just edit it together. They can have a look. So really, it just makes the access to data like really prevalent inside the whole company, which is amazing. All right, cool. Now go to the technology part. So I'm just going to move this somewhere again. Hopefully, this is not going to be hiding anything. Okay, cool. So let's talk about real-time collaborative editing. Let's say that we've got two users, okay? There is Alice and there is Bob. We are not going to talk about notebooks at this point because it's too difficult. So they are just going to be starting with a simple string. So there is, they both have string ABCD. Now, this is similar to Google Docs, you know, just like simple text that you are editing, and we are just going to find out how to do it. So let's say that Bob wants to do this operation. He wants to delete the character B, which is at position 1. So delete 1. Alice wants to do another operation, which is inserting X at index 3. So quite straightforward. Bob is going to end up with ACD. Alice is going to end up with ABCXD. So 0, 1, 2, X at position 3, and D. Super simple. But now there is a problem. We need to make sure that they are real-time collaborating. So they need to be able to share the data about their edits. The naive way, what we could do is just send this operation to Alice, send this operation to Bob, and let them apply them. So this is what could happen. I'm just going to take the string ACD, insert character X at position 3, and I'm just going to end up with this string. At the same time, Alice is going to take the character, the ABCXD, delete character at position 1, and she's going to end up with ACXD. But what you can probably see is ACDX is not the same ACXD. Those two characters are switched. So we've got a divergent state and everything is blown up, everything is horrible. So instead, what we can do is introduce another component. So let's say that I have a central server that is also managing these transactions, okay? What we can do now is the same scenario. Alice inserting X, Bob deleting B, okay? Now, they both tell the server, listen server, I just want to delete character at position 1, I want to insert X, and arbitrarily, even if it's happening roughly at the same time, the server says that this packet arrived first, so I'm going to execute this first, then this packet arrived second, so I'm going to execute this second, and now the server can tell Bob and Alice that this is the resulting situation. However, there is a problem. This can take quite a lot of time. So imagine that you are editing a document, you can write a character and then wait 100 milliseconds until it appears because the server needs to acknowledge your operation. Well, I'm guessing you would be very unhappy, you know. That's just going to take forever. So this is also not an option. So now there is another way to do this, and this way is called operational transformations. Okay, so well, I'm just gonna. The situation now is similar as we have had before. So again, Bob and Alice, same string, and now wait. Now what happens is that they are going to apply the operation delete, insert. The server is again there, and the first operation is easy. It just arrived. It's applied, and now the state is ACD. Okay, so the server has its own internal ground truth state, and this is ACD. This is the basis of operational transformations. But now there is the second operation, and because we have applied the delete operation first, we need to transform the second operation. So we can see that the insert X at position 3 became insert X at position 2. This is the transformation that just changed the index of insertion because the delete operation was applied before. It obviously makes sense, you know, like I wanted to insert the character after C, but something got deleted, you know, so I just need to change the offset. So this is probably what Alice wanted to do. Alice wanted to write an X after C. It's not like Alice wanted to write it in a specific index. So the meaning of the operation is preserved and the operation got transformed. So now the server has the correct state. Server knows that the state of the document is ACXD, if that makes sense. Now, moving on, we've got a new situation. So now when ACXD is the server is the state, we need to tell Bob and Alice about this change. It's simple to tell Bob, right? Because we can just tell Bob that after you applied your delete, which already happened, you can insert X at position 2, which is already the transform operation. Bob's ends up with ACXD. Okay. Now we go to Alice. So Alice has now already inserted, as you can see over here. I just went one slide back. Alice has already inserted her X. So now the problem is that we need to roll back the operation that Alice did. So the first thing we do is we roll back the operation, then we apply the deletion, and then we apply the new insertion. So this is similar to how Git works. And this is also the basis of operational transformations. So the first operation is rolled back because the server didn't accept it. And the server tells you what are the other operations. And now what you can see is we've got the same state. Both Alice and Bob have the same state, which is amazing. And they can type without waiting for the server to acknowledge information. But sometimes if server says no, they need to roll back and apply the changes again. Cool. Now let's introduce yet another guy. So this is Chris. Sorry if this is getting too complex. Any questions so far, or? Okay. I take silence as understanding everything, so I'm just going to move on. So there is Chris. Chris was online before. He was at the same state with ABCD. But now what happened is that Chris lost connection to the server. For example, he was traveling from Bratislava to Brno. There is no internet all the time in the train, so he lost connection. And now Chris needs to come back online after those two changes got applied. So what happens is that the version of Chris's document is V0. You can imagine version as like ever increasing number each time an operation is applied. So we applied 2 operations, version here is 2. But Chris is version 0. So Chris knows that the server has version 2, I've got version 0, so I need to ask server for more data. So Chris goes to the server and says, please give me operations 1 and 2. A server just gives Chris the operations, and Chris applies those operations, and Chris is back online and has all the right data at the state. If Chris was typing when he was offline, the same operation would happen as we explained with Bob and Alice. So everything Chris typed is going to get rolled back, and then all the operations from the server will be applied, and then all Chris's operations are going to be applied on top of whatever came from the server. So this is how it works. If you are familiar with Git, this is very similar to what happens with Git rebases. If not, I hope this was kind of interesting. This is how Google Docs are working, and this is also how DeepNote is working. So operational transformations is the way. But now we only talk about strings. So just like simple textual strings. What happens with notebooks? So as I mentioned at the start, notebooks are just big JSON files. Okay, so it's a JSON object, or similar to dictionary in Python. It's just like keys and values that are mapped together. Luckily, the operational transformations have implementation for objects or for dictionaries. So it's pretty much saying, you know, for example, this is an operational transformations that inserts an object on this path inside JSON. It's not too important to understand this. The point is that you can simply apply the same algorithm I was talking about here to notebooks with just like a simple extensions. So what is going to happen with our architecture over here? The only thing we need to do right now is replace the notebook server with like a special notebook server that is capable of handling operational transformations. So right now, if this is an operational transformation component that can do the collaborative deconflicting and all that, what we can do is just connect another user over here to the same operational transformations component. And when they ask for something to be executed, the state here gets sent to the kernel, you get the results, and otherwise you are just typing using the string transformations as I have explained. So it's actually fairly simple. We replace this one component in the architecture and everything just works nicely. The only problem is that you also need to replace the browser so it can communicate with the operation transformations component. So this code would need to change as well. Nice. Any questions so far on operation transformations or just like collaboration on strings? I know this has been quite a mouthful, so I'll be happy to also answer the questions later on if anyone is interested. Cool. I've got another couple of...
Sorry, there's a one question on Slido regarding what if Bob wants to edit the same object as you? So regarding the git merge conflict. I think you explained it, but if you could just quickly go through that. Okay.
So it really depends on the situation. So for example, if you are changing text, this is fairly simple. But if we are working on notebooks, so for example, one of us can be changing a specific cell, so maybe adding some code, and the other person can delete this cell. This is obviously an operation that is impossible to recover, so this is some sort of a possible conflict. The operation transformations algorithm itself can resolve the simple conflicts. So for example, if there is a deletion, like no edits make sense on that object, so they are just deleted. And otherwise, in the worst possible case, when there is a conflict that is not recoverable, what we can do is just tell the user like, sorry, this edit was conflicted. You can just, you know, the edit was thrown away and you need to start working again. This is usually not such a big problem because if you are connected, we are syncing the data really quickly. So within a couple of seconds, the state is consistent. Otherwise, if you are just offline for like 2 hours and then connect back, sometimes you might lose some part of the edits. That's just how it is. So the recommended way of using the operation transformations is to be more or less online. Okay, I hope that answers the question, and I'm moving on. Cool. Okay, so we've got another thing. So apart from notebooks, many data science workflows require you to use terminals to install stuff, to configure stuff, or to really just do whatever. So we were thinking about whether we want to make terminals collaborative as well. This is super controversial, but we have decided like, yeah, everything is collaborative. So there is also a nice use case for it, you know. If you are teaching your student to use, for example, Git, we talk a lot about Git and it's a difficult topic. You can just like fire up terminal and you can type and people on all connected people just see the same results. And this is interesting because we don't need any sort of operation transformations or anything difficult for this, because in terminals, when you type something, there is a chance that the character is not going to appear on screen. For example, if you are using Vim as your editor, you can navigate using J and K throughout the file. So if you write J, no J appears on screen, but your cursor is going to move down. So really what we need to do is wait for the server until it acknowledges the message, and then it actually writes the results back. So whatever is the ordering of the messages is just going to be followed by the server, and that's pretty much it. And really, this slide is interesting for you guys, because if you are using SSH or secure shell to connect to any sort of like a remote machine, something in the cloud, whatever, you might be used to this, because if you have bad internet, high latency, then typing in SSH is very painful. So what you can use instead is a tool called Mosh. Mosh has a thing called speculative local echo. So what it does is that if it sees that when you are typing, the characters are appearing on the screen, it's not going to wait for the server round trip, but it's going to let the characters appear immediately. And if it sees that like you are typing, characters are not appearing, but something weird is happening, for example, the Vim navigation, then Mosh is just going to stop doing it and instant just wait for the server for the acknowledgement. So using experience of using secure shell or SSH is much, much worse than using Mosh if you have slow internet. So this is just something that is cool, and we are thinking about implementing speculative local echo in deep node in the coming weeks and months. So this is not yet there, but it's going to be there, and it's going to make the experience much nicer. Cool. Moving on to security, it's going to be very quick. But as you can imagine, taking your local data science environment to the cloud might have like a lot of security implications. So first thing we need to think about is the browser security. And the biggest issue there is cross-site scripting, or XSS. So what can happen is, this is by the way the most common security vulnerability. It surpassed buffer overflows as the biggest security vulnerability a couple of years ago. So what can happen is that in a Jupyter notebook, you can have a client-side JavaScript. For example, you have like some fancy interactive component, for example, from Plotly or Folium or similar libraries. You can have a component that is, there is like some sort of widget, that you are using to control your execution or something. So this is client-side JavaScript. But there can be a bad guy. So for example, if I wanted to steal Jan's data, what I can do is I can create a notebook which has a client-side JavaScript saying, take Jan's cookie and send it to me. If Jan opens this notebook, the cookie is just going to get sent, and Jan is spawned, and I can steal his identity. So there are two ways to mitigate this. One is sanitizing the outputs. So this would mean that we can just strip all the JavaScript from all the notebooks and say that no JavaScript gets executed. But this is bad experience. The other option is iframes. So this is what we are currently doing. So all client-side JavaScript is embedded in an iframe. So it really like a browser topic, but what's happening is that we sandbox the JavaScript, so we cannot steal cookies, and we can, the attackers cannot really do anything with the local storage of the browser. So it's really a sandboxing topic. Also, Jupyter is doing this. Maybe you have seen the concept of trusted notebook. So you can tell Jupyter that you trust this notebook, and at that moment, Jupyter actually executes the JavaScript. If you don't trust the notebook, Jupyter just strips away the JavaScript, so like some interactive thingies are not working. So this is why the trust is there. Okay, another thing is that like in Deep Node, what you can do is run your computer science environment or data science environment in the cloud. What we do is behind the scenes, we create a container that is actually running all this. You might have heard about containers from DevOps people. It's like the topics of Docker and Kubernetes and so on. One thing I want you to take away from this talk is that containers actually do not contain. That's the name is wrong, because they are not really a security boundary. If you don't know what you are doing and you let arbitrary person inside the container, it's not that hard to actually break out of the container and be like a root user on your actual machine. So there is a lot of ways to prevent this. What we are doing is stripping operation system capabilities, creating a lot of network restrictions, and also sandboxing whole container inside the application space. This is all a bit of advanced topic, so please remember containers do not contain, because this is the interesting stuff. And if you have any specific questions about this, I'll be happy to answer them after the talk. Okay, now what the time? Seems like I've got like 2 minutes for the demo, so I'm just gonna quickly run through this. So this is Deep Note.
You can take even more if you want. No, don't rush so much.
Okay. So sure, I'm just gonna roll with it for a moment. This is Deep Note. This is a bit of a like maybe familiar ID interface. You can see there is like a file system over here, and this is like the main project view where you've got a cell. I'm just gonna populate it with something. So there's like this sample project. So we have something to quickly talk about. This is similar to Jupyter. In Deep Note, you can execute your cells, your code. This is all running in the cloud inside your own container. And the cool thing is that you can actually share it with people, as I mentioned, right? So you can share it by a link, or you can invite like your colleagues or something. So for example, my colleague is actually in the talk, so I'm going to invite him here so he can collaborate with me on the notebook itself. I'm hoping he's around. Well, we'll see if he connects. Okay. In the meanwhile, what you can also do is, for example, visualize data in CSV. So instead of like the classic Jupyter output that you can see over here, we are adding like a lot of nice histograms and just like making the data exploration tasks much easier inside Deep Note. There is also like actual visualizations where you can plot the variables and so on. If you need stronger machines, stronger hardware, there is like options. If you connect, there is more options you can get. Oh, it seems like Jakub just connected. Let's see what he's up to. It does not seem like he's in a notebook yet.
Sorry, I logged in with different email, so I can only view.
Okay. Anyway, while Jakub sorts out his email situation, if you want to bring your own container, there is like a specific custom Docker file, so you can install whatever libraries you need. You can connect like a bunch of different integrations, you know, the classic Postgres, Mongo, S3, whatever you need. You can use Git. I talk a bit about terminals. So as I mentioned, you can just like spawn terminals, even become super user. So install whatever you want, whatever we need. Maybe let's come back to see if Jakub is around. It seems like finally someone is in the notebook. But still not Jakub apparently. So in the meanwhile, I can show you that if Jakub is not coming, we can just leave him a comment. I don't know. We can just post it here. Oh. And oh, I got a question in chat. Oh, what component do we use for web terminal client? Coming back to the terminal, this is Xterm. I'm not sure what's so yeah, as I mentioned, you can see that this is a tiny bit slow, just because this is still going back and forth to the server. But with the speculative local echo, it should be much faster. And yeah, the component is Xterm. Okay. I guess this. Oh, it seems like there is somebody over here. Just to simplify this tiny bit. I can just change this link and open it in another tab, I guess. there is a lot of people now. Over here, I can just type and you can see, like the classic collaborative cursors. This is the other me collaborating at the same time. Cool, awesome. So coming back to the presentation. I think my internet died because I can't even change the slide. Okay, anyway, the last slide was just thank you for your attention, so I don't think I need it. Cool, that was pretty much it. Any questions right now, or should we wait for the breakout rooms?
Thank you very much. Thanks for the talk. Luckily, your internet connection may be down, but you're still heard, so that's fine. So
okay,
only
nice.
There are actually 4 questions on Slido.
Awesome.
So I can read them. So first of them is, would you recommend DeepNote for teaching?
Yes, I actually would recommend DeepNote for teaching. We actually have like a lot of already running teaching engagements. University of Cambridge was running one course in DeepNote in spring. So the professor was super happy about it, because now like all teaching is going on remotely. So there was like a couple of groups, and like the professor could literally just like come into the group's project and help them with things. Same with teaching assistants. So Cambridge people had like a really amazing experience, and now we've got another teaching engagement at Harvard University, and from the big names, and then we've got like a bunch of teaching engagements at like other universities around the world. A lot of them in India, for example. So people are using DeepNote for teaching already. It's going quite well.
Okay, thank you. Another question: what is the difference between DeepNote and Google Colab? So
okay, sure. So Google Colab is not actually collaborative. That's like a funny thing. Right now, if you want to collaborate on Google Colab, you need to actually save the actual notebook to Drive and then like open it elsewhere. So the real-time collaboration component was there for a while. It's not currently there. It's because the underlying library got discontinued at Google. Otherwise, you can't do a lot of other things in Google Colab, so there is like no first-class integration with like different other tools. There is, you can do, for example, sudoing in terminals, and also Google Colab just like randomly interrupts your computation. We don't do that. So right now, if you run your compute for a while, it's just gonna be there when you come back. It's not like Google Colab that just randomly interrupts it after 30 minutes or 120 minutes. And also we are planning to build a massive bunch of other features, starting with those visualizations that I mentioned. There is a lot of other things that are just gonna be at the different edits at different stages after Google Colab. So you can see that there is pretty much feature parity. We are even better in some things, and well, Google Colab has been around for a while. We've been around for just a shorter while, I guess.
okay, another questions. Are there any JavaScript incompatibilities between classical Jupyter Notebook and DeepNote, such as there are between Jupyter Notebook and Jupyter Lab?
Yes, so right now we are supporting all the classic IPyNB format. If you want to come to DeepNote, you can just bring your own Python and IPyNB. But with respect to JavaScript incompatibilities, yes, there is a couple of issues. So for example, right now we've got some trouble running some visualization libraries, for example, Volume, just because of the security concerns. We did not want to implement the trust I mentioned, because it's just confusing for people. Like a lot of people don't understand the concept of cross-site scripting, don't understand the concept of trust and what it means. So we just want to avoid this, and we are using different measures, as I mentioned, those iframes. And this is introducing a lot of incompatibilities, but we think that security is more important than features right now. And we are instead just trying to fix volume in iframes as opposed to implementing trust, which was confusing.
Thank you. There are still 3 questions, so probably not more now.
Okay.
We will stop. After these 3, we should stop. Is it possible to run DeepNote server on the local server?
So right now it is not, because DeepNote is still like a work in progress product, and it would slow us down terribly, because then like we would need to do like a proper versioning issues, bug fixes, releases, and so on. So it's in our roadmap. We want to make some sort of a local DeepNote, but it's not coming in the next couple of months, or like we are not sure when it's coming yet.
Okay, another question. You talk about operational transformations. Have you considered CRDTs, which means conflict-free replicated data type?
Yes. Like it seems like CRDTs are the winner these days, but we could like a very specific use case. I'm going to go back to the slides really quickly, just to this slide over here. So we need this guy. We need a notebook server. And the reason is that like there needs to be some ground truth that is sending data to the kernel and sending the data back. CRDTs are peer-to-peer. So like you can collaborate between multiple users, but this guy would just be another user, and it would create all the race conditions and incompatibilities. So it's really important for us to have ground truth, and operational transformations have this sort of thing, like the ground truth is on the server. There is a lot of other things that made us do this decision. I can talk to you about it later if you're interested.
Okay, then the ultimate question. Is there some good way of storing notebooks in Git? Okay, good question. I mean, that only code could be stored and there would be conflict on cell execution. Okay.
Yes, I guess I can answer it. So there is no super good way. The recommended idea is that if you are committing a notebook, you should be clearing all the outputs, because really what's creating all the mess is the outputs. It's not the code. So if you clear all the outputs, the other people clone it, they can just rerun it. That's like the easy way, and that's probably what you should be doing. Otherwise, I don't have a better answer right now. But we are right now starting to build versioning in DeepNote, so hopefully this problem is not going to be there if you start using our product.